Hello, class. There's the old saying that says that if you're not part of the solution, then you're part of the problem. In chemistry, we twist that up just a little bit and we say, well, if you're not part of the solution, you're part of the precipitate. So, what just does that mean? Well, let's take a look at your textbook. What is similar about these test tubes and what is different? Well, besides the colors, although the colors are different, that's not really what we're looking at. You'll notice that in the first four, everything is spread out rather evenly within the test tubes. On the last two, you can see that there's a clear section and then a not clear and here a yellow section. These two test tubes have solids at the bottom. Now when we say solids, we don't mean like chunks of rocks and so forth, but rather solid, and it could be very, very fine powder. And that is what we call a precipitate if it came out of solution. So in your homework, one of the questions it asks you is to predict the solubility of the following compounds. So how can we do that? How can we predict whether or not something is soluble or insoluble? Is there some kind of a pattern? Well, the answer is no, not really. If you look further down in your book, there is a chart. And this chart, or this table, will give you some suggestions as to what are the most common guidelines as far as solubility is concerned. So let's take a little bit of practice with some of that solubility. So how do we know if something's soluble? First of all, our first example is sodium nitrate. Well, if the first thing we have to do is we've got to get a formula for that. Well, what if I don't remember? Just a reminder, you can go all the way back to page R78 and you can find the different ions here. And there's sodium, and it is a +1. And right across here is the nitrate, which is NO3 -1. So our formula for sodium nitrate is going to be NaNO3. Since Na is a +1 and NO3 is a -1, that is a balanced chemical formula. At this point, it's a solid. We're going to mix it with water. And does it form does it dissolve or does it stay as a solid? And we're going to look at our chart here. And guideline number 1 says sodium compounds are soluble in water. Notice there's no ifs, ands, or buts about it. But if we're not satisfied, or maybe our first element we can't find a clue on, we can go on down. Usually there's another one. You'll notice here it says nitrates. Nitrates are also soluble. So in both cases, we have ions that say, according to our chart, they're soluble. So this will form a solution of sodium, and we'll put AQ here, plus chloride, AQ, and it's soluble. All right, another example, barium sulfate. Again, how do we know? First of all, we need to know the formula. Barium, and you can look at our periodic table as well, and R78, but barium is Ba, and we know it's a 2+. And sulfate is SO4, and it's a -2. So I'm going to put a 2+ here just for now and a 2-, and we can see that those charges balance. So this also happens to be a balanced chemical formula. So we're going to mix it with water. And do we get a solution or not? Well, we'll go back to our chart. We don't see barium or sulfate in the first row. No barium or sulfate there. Barium or sulfate here. Nope. Oh, sulfates. sulfates are soluble. Okay. Except those of who? Barium. Okay, so barium sulfate is an exception. So that means that it is not soluble. So this is not soluble. Not soluble. Potassium phosphate, again, potassium phosphate is PO4. Potassium is a +1, and phosphate is a -3. And so to get this to balance, I need to put a 3 there. Now that I've got my formula balanced, I'm going to put it on here and say if we mix it with water, what do we get? Well, go back to my chart again. Potassium, oh, there he is, right there. Potassium is soluble in water. And let's say I didn't know if potassium was on the list. Let's check and see further. Most carbonates, phosphates. Phosphates are soluble. There are some exceptions, except those of sodium, potassium, insoluble. Most phosphates are insoluble, except potassium. Oh, so there's our exception. So this guy is soluble. And we are going to get K plus, and this will be AQ, aqueous, plus phosphate, 3 minus AQ. Now, up here we just had a 1-to-1 ratio, but here we've got a 3. So I have to remember to put a 3 here to balance my chemical reaction. And these two are what we call ionic equations. And that's the basics on how you can find out whether or not something is soluble.